Tonight, we're going to talk about something that keeps astronomers up at night. Not because they're scared, but because they're confused, genuinely confused. Out there in space, we've discovered things that don't make sense. Things that shouldn't exist according to everything we know. Things that break the rules. And I'm not talking about science fiction. I'm not talking about theories or speculation. I'm talking about real observations. Things we've actually seen and measured. Things that are out there right now doing whatever strange thing they do. And we have no idea why. Over the past few decades, as our telescopes have improved, we've stumbled across discoveries that have left scientists scratching their heads. Some challenge our understanding of physics. Some suggest there are processes in the universe we don't yet understand. And some of them are just plain weird. Let me start with something that happened on August 15th, 1977. A man named Jerry Eman was reviewing data from the Big Ear radio telescope at Ohio State University. The telescope was part of SETI, the search for extraterrestrial intelligence. Most days, the data was boring background noise from space. But on that day, Eman saw something so unusual that he circled it in red pen and wrote a single word in the margin: wow. The wow signal lasted 72 seconds. It was about 30 times stronger than the background noise and came from the direction of the constellation Sagittarius. Its frequency was around 1420 megahertz, right near the hydrogen line. Hydrogen is the most common element in the universe, and if an alien civilization wanted to send a universally recognizable signal, that would be a logical choice. The signal never repeated. Astronomers have searched that region of the sky for decades using more powerful telescopes. Nothing. To this day, the WOW signal remains unexplained. Either an extraordinary coincidence or evidence of something extraordinary. Now let's talk about a star that's been driving astronomers crazy since 2011, Tabby's star. Officially known as KIC 8462852, Tabby's star sits about 1,460 light-years away. It looks ordinary, but its brightness behaves in a way no other star does. Sometimes it dims by as much as 22%. Far too much to be caused by a planet. The dimming is irregular and unpredictable. At one point, scientists seriously considered whether it could be an alien megastructure, something like a Dyson swarm collecting energy from the star. While that explanation is unlikely, it was considered because nothing else fit. The current leading theory involves massive clouds of dust or debris, possibly from a catastrophic collision. But even that doesn't fully explain what we see. Tabby's star is still dimming in strange ways today. Then there are odd radio circles, orgs. Discovered in 2019, these are enormous, perfectly circular structures seen only in radio wavelengths. They can be hundreds of thousands, even millions, of light-years across. At the center of many of them is a seemingly normal galaxy. They don't match supernova remnants, radio galaxies, or any known phenomenon. As of 2025, no one knows what causes them. On an even larger scale, astronomers have discovered structures that challenge the cosmological principle, the idea that the universe is uniform on large scales. The giant arc spans about 3.3 billion light-years. Nearby is another structure called the Big Ring. These structures are far larger than our models say should exist. If they're real, and all evidence suggests they are, something in our understanding of cosmic structure may be wrong. Now let's zoom into emptiness itself. The Bode's void is one of the largest known supervoids, roughly 330 million light-years across. It's an enormous region of space, containing very few galaxies. While voids are common, this one is near the theoretical limit of how large voids can grow. The few galaxies inside it behave strangely. forming stars differently, possibly because they evolved in extreme isolation. This void likely originated from a tiny quantum fluctuation in the first fraction of a second after the Big Bang, a microscopic imbalance that gravity amplified over billions of years. It's a reminder that the smallest differences can lead to the largest structures. Another early universe mystery is the CMB cold spot. The cosmic microwave background is the afterglow of the Big Bang, remarkably uniform in temperature. But one region of the sky, about 10 degrees across, is significantly colder than expected. The odds of this happening by chance are about 2%. One explanation is that photons passed through a massive void, losing energy through the integrated Sachs-Wolf effect. But even the largest known voids can't fully explain the cold spot. Another, more exotic idea involves collisions between universes in a multiverse. Or it could just be a statistical fluke. As of 2025, the cold spot remains unexplained. Then there's Przylski's star. This star contains radioactive elements like technetium and promethium, elements that should decay away in a few million years. Yet, they've been observed in its spectrum consistently for over 60 years. The star is billions of years old. The elements shouldn't be there. Scientists have proposed unknown nuclear processes, exotic super-heavy elements, or strange atmospheric effects. None fully explain it. Przylski's star remains one of the most chemically bizarre objects ever observed. In 2017, something even stranger passed through our solar system. Oumuamua was the first confirmed interstellar object ever detected. It was elongated, reddish, showed no cometary coma, yet accelerated in a way gravity alone couldn't explain. Some scientists proposed outgassing or radiation pressure. Others, controversially, suggested it could be artificial, a light sail. Most astronomers favor natural explanations, but will likely never know. Oumuamua is already gone. In 2018, astronomers detected AT-2018 Cow, an explosion unlike anything seen before. It was extraordinarily bright, heated up rapidly, and faded in weeks. It didn't match any known type of supernova. Similar events have since been found and are now called fast blue optical transients. Their origin is still unknown. Finally, there's the Methuselah star. This ancient star appears to be nearly as old as the universe itself, possibly older. Its low metal content suggests it formed very early. Age estimates place it around 14 billion years old, while the universe is only 13.8 billion years old. The error bars barely overlap. Something is off. Either our stellar models or something deeper. All of these mysteries share something in common. They remind us that the universe doesn't owe us simple answers. Every time we think we've figured it out, nature surprises us. And that's what makes astronomy so powerful. We're not just learning facts. We're discovering how much we still don't know.